Hey there. So, before we begin, let me give you my brief introduction once again. My name is Dr. Mohammad Akid, and I'm a recent medical graduate. And I have more than 3 years of experience, and I've, I've taught various subjects such as biology, English, physics, chemistry, at the students at various different levels. So, let's start. So today, what we are going to cover is our first chapter that is quite basic about the chemistry, and that is called as atoms. So I went through this chapter, and it's quite detailed. So maybe we won't be able to cover the whole chapter in this one session, but we'll try to cover it as much as we can. So let's get right into it. So in today's class, we're going to cover about the basics of the matter, first of all, like what the matter is. And other than that, we are also going to cover about how the matter is classified, like what are the different states of the matter, and uh, how do we classify the matter into different compound. Like a matter is anything that we can touch and feel, that we can see in the layman terminologies, not in the fancy chemistry, uh, not in the fancy world of the chemistry, but anything that we can see, touch, and feel, that is the matter actually. But how do we classify the matter? We are also going to study about that. And what are the different states of the matter? That is solid, liquid, gas, plasma. And these are the classification of the matter. And we are also going to study about elements. What are the elements, and how do elements combine and form different substances? And these substances are, they can be compounds or they can be mixtures, and we are going to study about that as well. And other than that, we're going to study about the scientific method. And this scientific method is not something that we can only study in the field of chemistry, but we study it in physics, in basically any scientific subject. We follow the same scientific method. So, scientific method, we're going to study about that. And once we cover all that, we are going to study about the atomic theory and the history of atomic theory. Like, how did scientists came to know about the substance called as atom? Okay, and what is atom exactly? And how did they know that there is a thing called atom? So first, we're going to study about the how exactly the atom, uh, how exactly did they discover the atom? And once they discovered the atom, they slowly and gradually modified their theories. Each and everyone contributed. Like, there are many scientists that contributed to this atomic theories. First of all, there comes the Democritus, and then comes the Dalton. There, and after that comes J.J. Thomson, and their different experiments. We're going to study about that. And after that, once the atom is discovered, now and then we are going to talk about the subatomic particles. That is, the atom. At first, they used to believe that atom is the most basic particle, like most fundamental unit of everything is atom. But later on, they discovered that atom isn't the most smallest and simplest particle, but in fact, atom is also made up of subatomic particles, that is, electrons, protons, and neutrons. There are other subatomic particles as well, such as positron, neutrino, and various other subatomic particles as well. But we are going to jump on it later on, maybe in the next few chapters. But these are the basic subatomic particles that we are going to study about in this chapter. And after that, after we cover the subatomic particles, we're going to study about the isotopes and the atomic mass and other basic terminologies such as atomic number. And we are also going to discuss about the concept of mole, Avogadro's number, significant figures, and these are some things that are more to do with the numerical stuff. Okay, so we are going to have some overview about that as well. So let's get right into it. So let's start from something you already know. So we'll start from what matter is. So anything that we can see, we can feel, and we can touch, uh, that is the matter, basically, in the layman terminology. Okay, so this is that is something called as matter, and matter, as we know it, are made up of matter is made up of smaller units that are called as atoms. The most basic unit of the matter is atom. Okay, and different atoms combine together and form molecule. Okay, so this is pretty much the basic of any chemical compound, anything, any element. This is pretty much a basic stuff. Okay, so atom is basically the most fundamental unit. So let's start from something that you already know, and that is the matter. Okay, so in the layman terms, in the common terminology, matter is something that we can feel, we can touch, anything that you see around, that is the matter. And this matter is composed of atoms, which is the most basic fundamental unit. And these atoms, they are arranged in a certain manner and they combine in a certain way and they form molecules. Okay, and these molecules are stick together and they form either element, compound, or mixture. We will discuss about it later on, but this is pretty much how everything that you see around uh, looks like from inside. So in the matter, there is nothing but atoms, and atoms, they are combined together in a certain way and they form molecules. And these molecules are stick together with the help of intermolecular forces, and this is how any substance is formed. Okay, so another thing that I'd like to mention here is that the structure of the matter, that is the arrangement of atoms, then the arrangement of molecules in a certain way determines how the properties of that substance will be. For example, the same H2O, and H2O is a compound of, sorry, it's the formula of water, but it's also the same formula for the ice. It's also the same formula for the steam, but they act very differently in the environment. Steam is a gas, ice is a solid, and water is a liquid. So all of them have different properties, and yet chemically they are same. So this is a matter of how the atoms and molecules are arranged. we are going to look at another example, and I'll show you. Yeah, you can look at it. This is the molecule of a diamond. Okay, so this is a molecule of diamond. Okay, so diamond is basically nothing but the carbon. Okay, and this same carbon has many forms. Coal is also a carbon, and graphite is also a carbon. We are going to discuss it just after this. So I'm just showing you how the diamond, that is the a form of carbon, it's basically an allotropic form of carbon. And in the diamond, here is how the atoms are arranged. One carbon atom is combined to four different carbon atoms, just like this, and they are very tightly bound together. And because they are very tightly bound together in a covalent bond, the boiling point, the melting point of this diamond is quite high, and it's also very hard in texture. On the contrary, there is another carbon that we just discussed right now, that is the graphite. And you can see that in this uh, form of carbon, that is graphite, each carbon atom is bonded by three other carbon atoms. One, two, three. So each carbon is attached to three carbon atoms by covalent bond, and it's connected to the fourth carbon atom by means of weak van der Waals forces. It's a type of intermolecular force that we are going to discuss later on. But I just want you to remember that this is a bond, but it's not a primary bond. It's an intermolecular force, and it's called the van der Waals forces. And it's quite weak. So three covalent bonds and one van der Waals forces. And because of this, because there is a different arrangement, you can see that these are the hexagonal rings. And in case of diamond, it was like a cube. Okay. Uh, Let me show you again. Yeah, you can clearly see the difference. So the only difference between the diamond and the graphite is their arrangement of the atoms. Okay, so the arrangement of the atoms is different, and this makes their properties so different. Okay, so this is how the arrangement of the atoms and molecules determine the different properties. Okay, there is another example of oxygen. Here is the molecules of oxygen gas, and this is oxygen bonded to another oxygen atom, that is called as O2. Okay, so in the O2, because this is a gas, so it occupies a larger space, and hence it's compressible. Again, it's also because how it's also because of how they are arranged, how the atoms and how the molecules of oxygen, they are arranged in a in such a way that it's easily compressible. It's not compressible. Diamond. Diamond is not compressible. If we look at this, for example, even if we look at the graphite and the diamond, they are not as compressible as as oxygen, because the graphite and the diamond, they are both solids, and they are both bonded by covalent bonds, and they also have intermolecular forces. Whereas this oxygen, they don't have any strong forces that are binding the molecules together. They are very loosely bound. and hence they are compressible. Okay, so this is another example of how the properties of the molecule are determined by the arrangement of the atoms and molecules. Okay, so let's see what's next. Yeah, so this is another example of how the properties of, so this is another example of how each and every aspect of the arrangement that is so important in case of properties, determining the properties. For example, this is real water that is bent shaped. And it has an angle of 104.5 degrees between the oxygen and between the two hydrogen atoms, and it makes a right angle that is slightly not right angle exactly, but a little bit obtuse angle. Okay, and hypothetically, if it was linear, it wouldn't have been possible because it wouldn't have as much of boiling point, and it wouldn't dissolve salt or sugar, and it wouldn't act as the normal water. So this is how very small changes in the you know arrangement of the atoms make a difference, make a huge difference in case of the properties. So let's uh, go to the next slide, and that is the classification of the matter. So till now we studied about what is matter and how the matter is composed of atoms and molecules, and the arrangement of and how the arrangement of atoms and molecules make a difference. Okay, so now we are going to classify the matter. Okay, so the matter can be classified into either it's pure or impure. For pure substance, it means does it have only one kind of atoms or molecules, or does it have different kind of atoms or molecules? For example, you take a substance such as uh, iron. Okay, so when you take a piece of iron and you break it, and it's, for example, it's a pure iron, and so it has only one kind of atom, that is Fe. Okay, that is iron. But uh, if you take a mixture of iron and tungsten powder, and and their powder are mixed together. So when you take any sample from that mixture, you can have iron or tungsten. Okay, so a key point to differentiate this thing is when you break a substance and you only find only one kind of atom or molecule, that is a pure substance. And if you take a substance and you break it, or you take a sample from that substance and you can find more than one kind of atoms or molecules, then that means it is a mixture and it is a impure substance. Okay, so matter can be, it can be pure substance or it can be a impure substance. And if it is impure, it means it's mixture. Anything that is not pure, it's mixture, obviously. So pure substance and the mixture. And this pure substance is also further classified into whether it is an element or whether it's in a compound. So what's the difference between element and compound? So a compound is basically nothing but a combination of elements. Okay, but bear in mind that this combination is a lot different from mixture, because in case of mixture, you just take two substances, you mix them together, and that's it. Okay, but in case of compounds, you take different elements and you react them together. For example, you take the sodium, you take the chloride, and you make them react with each other. And they both have different properties. The reactants, the one that are going to react in a chemical reaction, they have a completely different properties. Okay, sodium is a very it's a solid. Okay, it's very reactive solid. Okay, and chlorine, as I know, chlorine is a gas. Okay, so one is solid and another is gas, and sodium is quite a reactive solid. It cannot, in at the room temperature, it reacts quite strongly. So it's a reactive solid, and chlorine is a gas. So when you react them together, and you get NaCl, okay, that is the salt. And salt at room temperature is quite stable. So NaCl has completely different properties from chloride and uh, from sodium. It's completely different from chlorine gas, and it's completely different from sodium. Okay, so this NaCl is a compound, and the sodium and the chlorine gas, they both are elements. I hope it's clear. And mixture, we already discussed, it can be homogeneous or it can be heterogeneous. Okay, so homogeneous mixture is something that is uh, very uniform. Okay, homogeneous means uniform. So for example, air is a mixture. Air has carbon dioxide, it has oxygen, it has nitrogen, it has helium, it has neon, argon, it has so many gases, but it's a uniform mixture. Okay, whereas if you take a mixture of sand and water, you can mix them well, but you can see that water is, when you mix water and sand, you will sand is looking like it's not a part of the water, it's something else. And when you look at the water, you kind of feel that these both are not looking as uniform. Okay, so this is simply the heterogeneous mixture. Now let's discuss the states of the matter. So now let's discuss what are the states of the matter. Okay, so there are three states basically. There are more than three states actually of the matter, but here we are going to study about the three basic states of the matter. That is solid, liquid, and gas. Okay, so it's pretty simple, and I'm pretty sure that you've studied in the past class, in the previous classes. So solid is something that has a very fixed shape and it has very fixed volume. Okay, and it's not compressible at all. And in the solids, the molecules are very tightly bound together. In case of liquid, the molecules are also tightly bonded together, but they are lit as compared to the solids, they are relatively little bit less tightly bonded together. And in case of gas, the molecules are very far from each other. They are very loosely bound from each other. Okay, and the gas have very less. You know, it's it has no fixed shape, it has no fixed volume, and it's highly compressible since the molecules are quite away from each other. Okay, so this is pretty basic stuff. So let's move next. And here's a little quiz for you. So Sweden tea is classified as pure compound or element or homogeneous mixture, heterogeneous mixture. This is just a little quiz for you. So um, the answer is written right here. So let's move to the next topic, and that is the scientific method. Okay, so the scientific method is something that is how the scientists work on an idea. Whenever a scientist makes a theory, it doesn't just happens overnight. Like for example, uh, the Albert Einstein proposed the theory of relativity. He didn't just say that I think this. I think that this happens because of this, and that's why this is my theory. Okay, so they go through a proper method, they go through a proper channel, and that proper channel, that proper method is called a scientific method. And it's very important that we follow the scientific method. If any theory or law comes into being, it goes through this whole scientific method. So how exactly the scientific method works, let's find out. So first of all, the number one step in the case of scientific method is observation. First thing that happens is observation. For example, there's a plant. Okay, for example, there's a plant, and the plant doesn't the plant is dying actually. Okay, so the plant, you look at the plant, you think that this plant is about to die. Okay, you see that the leaves of this plant aren't functioning well. They have become brown and it's about to die basically. So this is your observation, and now based on your observation, based on your on what you see, based on what you've noticed in the plant, now you hypothesize, you make your hypothesis that this plant might need some water. And because there is a lack of water, there is uh, this condition of the plant. So, in order to test your hypothesis, you do an experiment. You What you do is you take two plants, for example, okay, or you basically split the same plant. So, sorry, splitting would be a little bit hard. You basically take two plants that are in the same condition, that both of them are dying. You give water to one plant and you don't give water to another plant. Okay. So